Lesson 8-5, Variation Functions. Objective, recognize and solve direct and joint variation problems. Recognize and solve inverse variation problems. Let's take a look at this word direct variation. Direct variation can be expressed in this form, and hopefully you recognize that is aligned. We call K the constant of variation. Let's suppose it's a relationship between the length and the height of something, the length and the height, and you can see it's a straight line. This straight line represents the direct variation, L equals 1.5 h. Now the 1.5 also represents the slope of that direct variation equation. As the height gets bigger, notice the length gets bigger as well. So there's this direct variation that the variables are increasing, both increasing at the same time. A very famous direct variation is that between the circumference and the diameter. When the diameter gets bigger, the circumference gets bigger. And so we have this relationship that we know, C equals pi d. Pi is acting as the constant of variation. So we can substitute instead of pi, we can write k. D is acting as the input, which we call x, and C is acting as the output, which is y. So you can see that relationship right there. What's interesting is if you have one set of points for the circumference and the diameter, and another set of points for the circumference and the diameter, they all equal that slope. And that's because if I divide both sides by x, like this, then I am going to get k equal to y over x. So all points, their ratio is going to be this slope. Let's take a look at some real-life examples. For instance, a car travels x hours with a speed of 60 miles per hour. That produces a distance. So distance equals 60 times x, the number of hours. And we can isolate the constant by just dividing both sides by x here. A man buys x bricks that cost $1.50 each. That results in the cost. So here's the cost, $1.50 by the number of bricks. And again, you can isolate the constant by dividing both sides by x. Here's another one. A tree grows x months by ½ meters each month, and that represents the growth. So here's the growth, here's the number of months, and we can isolate the constant by dividing both sides by x. So a direct variation, again, hopefully you will recognize that it looks like this. So we have a set of points that work for the direct variation, another set of points that work for the direct variation. We're going to isolate k, so now k is by itself. And because k is the same for the two sets of points, we're going to put these two ratios together and create a proportion. And this is the manner in which we're going to solve some problems. But first, let's take a look at just looking at a variation problem where they ask us to identify what the equation is. So we want to find the equation. And all of these look pretty much the same. Let's go ahead and write it. Y equals kz. So what we're looking for is the k. Which k do we want for our problem? So we've written out the direct variation. Y varies directly as z. You can see I have that. And now I'm going to put 19 in for y, and I'm going to put 152 in for z. So k is going to be equal to 1/8. So I'm going to look for an equation where the constant is 1/8, constant of variation is 1/8, and that looks like it's going to be A. Your turn. And here's the answer. Let's take a look at a direct variation where you're given one point and you want to find another. So again, we have a direct variation. Y varies directly as x. I am going to divide both sides by x. And so now I get my constant equals to y over x. So I'm going to substitute one point, y over x, another point, y over x, which I've done here, cross multiply, simplify, and then find your answer. So the answer to the question is when x is equal to 3, the value is -9. Your turn. And here's the answer. Let's take a look at what we call a joint variation. Joint variation occurs when one quantity varies directly as a product of two or more other quantities. So now we have y equals to our constant, but instead of just x, it's a product of x and z. We're going to do much the same thing. We're going to have our set of values in one of our equations. We're going to isolate k. Another set, we're going to isolate k. We're going to make k by itself. And then we can take these two and make them into a proportion. So let's take a look at this problem. So this problem says y varies jointly as x and z. So I have my constant of variation, and now this is the product here. So I'm going to isolate k, and I'm going to have one set of values here, another set of values here. I'm going to substitute them, cross multiply them, simplify, and divide. And the answer to the question is find y when x is 10 and 5, y will be 25. Your turn. And here's the answer. The next kind of variation I want to talk about is an inverse variation. And in this variation, the product is equal to a constant k. In this kind of thing, it's described when one quantity is increasing. So when one quantity is increasing, the other quantity is decreasing. And so that's why we call it inverse. They're not both increasing. One is increasing, the other is not. We call this varying inversely with each other. Now, what does that relationship look like? Well, it looks like this. Y is equal to k times 1 over x instead of x. And I hope you recognize that as the reciprocal function. I can multiply both sides by x, and when I do that, these x's reduce, and I get k is equal to x times y. And that's where I was over here. It's the product that are all equal to k. Instead of the ratio, it's the product. And that's because we came from here. So when you have one set of values and another set of values, you can make them equal to each other. All right, let's take a look at this. Y varies inversely to x. So this is that reciprocal function. They're asking us to find the form or the equation that has this as its points. So what I want to do is I want to put 45 in for y, and I want to put 7 in for x, multiply both sides by 7, and that'll be 315. So now y is equal to 315 times 1 over x. And so that looks like this answer right here. Your turn. And here's the answer. Let's go ahead and do a problem where we're given 1 point and we have to find another point. So given 1 point and another point. R varies inversely as t. So let's go ahead, let me erase this and let's just use the values that they gave us. Instead of x's and y's, let's use these letters here. So R varies inversely, so we have this k times 1 over t. There we go. And if I want to get k by itself, I'm going to multiply this side by t and this side by t, and then we're going to have this product. So here's the product here, and here's the product over here. I'm going to substitute my values, -6 and 2, and then I'm going to substitute t and then r sub 2 here. And then solve, and I'm going to get my answer. R is 12/7, and you can leave it as an improper fraction, that's fine. Your turn, and here's the answer. Let's take a look at a problem that we can apply here. It tells us that the length of a violin varies inversely as a frequency of its vibration. So I know it's an inverse relationship. Let me try to use the letters that they're using. So it says vibrations, so that's V, and the frequency as the frequency of its vibrations. Okay, so V is equal to K times 1 over F. All right, now what we want to do is we want to solve for k, and when we solve for k, we're going to get v1 times f1 if we multiply these two, and we know that that's going to work for any other set of points as well. The product will equal to the product, because when you multiply by f on both sides, you're going to get this. So I'm going to use f1 here, that's 10, and then I'm going to times it by 512 equals and 8, and what I'm looking for is that other frequency. So f2 is equal to 10 times 512 over 8, and does 8 go into 512? Let's see. So it goes in 64 times, and so the answer is 640 equals f of 2. Your turn. And here's the answer. Let's take a look at another problem. This says distance is stretched by a hanging object varies directly to the weight. So I went ahead and wrote my direct variation. Notice that it is like aligned. And so now I'm going to put my values in. So I'm going to write d1 over w1 is equal to d2 all over w2, because when I divide both sides, I'm going to get this ratio. So the distance is 29 over the weight is 6 equals, and then I want this distance, and then 25 here. So this is going to be 29 times 25 all over 6 is equal to D2. And so that's going to be, when you put this in the calculator, that answer should be A. Your turn. And here's the answer.